Okay, there we go. Now we're recording. All right, so we're doing configuring advanced DNS. We went over chapter 2 last week. I went in a little bit early, so we wouldn't have as many to go over this week. So that one is already out there and uploaded on YouTube. All right, so managing DNS zones. If your network has frequent changes to IP addresses and hosts coming online and going offline often, you might need to change zone transfer settings for standard zones and configure zone scavenging to delete stale resource records. Zone delegation. Zone delegation, transferring authority for a subdomain to a new zone. When a subdomain has been delegated to a zone on another server, the DNS server hosting the parent zone maintains only the NS record, pointing to the DNS server hosting the delegated zone. When the parent DNS server receives a query for the subdomain, it refers the query to the DNS server hosting the subdomain. Automatically delegated zones on domain controllers. Every Windows domain zone has an MSDCS subdomain, which holds all the SRV records for Microsoft hosted services. In the forest root domain, this subdomain is delegated to a new zone on the same server. MSDCS is created as a subdomain so that Windows clients and other clients specifically looking for a Microsoft service can query DNS for the service in the MSDCS subdomain. So here's an example of what that looks like in your DNS manager. So all it has to do is go out there and look for that underscore MSDCS and then look under there, and then it can find it a little bit easier. Configuring zone scavenging. For some reason, whenever I hear this, it makes me think of vultures. I don't know. Anyway, scavenging is the process of scanning the records in each zone and deleting stale records. So why do you think they do this? Exactly, right. Yeah, to free up resources, to stop people from having spoofing. That's a good possibility. Keep query times down. Yeah, you can cause all sorts of issues with query times if you have random records and stuff sitting out there just piling up. It's better to have scavenging run instead. Enabling scavenging you have to enable it in two places. On the server, you can go right click on the server icon in the DNS manager and click properties. Like I said, pretty much most of those things, right click and go to properties. Click on the advanced tab, click the enable automatic scavenging of stale records, check box. For specific zones, parameters set at the zone level override those set at the server level. So you remember me talking about how DNS and DNS rules and things like that kind of work the same as firewall rules. They're top down. So the ones at the zone level, those override the server level. All right, so here's exactly what they're talking about. There's that nice little checkbox. And then they have the refresh interval, no refresh interval that you can set there. Scavenging process is set to 7 days by default. When using Active Directory integrated zones, you don't need to enable scavenging on every DNS server. Zone data is replicated to all DNS servers, so scavenging needs to be enabled only on one server. Scavenging consumes server resources. Enabling it on a DNS server with a fairly light workload is the best. So if you only have to do it on one, okay, so let's make an example here. So let's say you have 7 of these servers and you have varying resource uses on those servers. Go out and take a look at your servers and resources and then pick the one that has the lightest workload and then enable the scavenging there so that you have the best usage of that. Stub zones, we talked about this a little bit previously. They're special types of zone that contain only an SOA record, one or more NS records, and necessary GLUA records to resolve NS records. Reasons for using stub zones are maintenance of zone delegation information. You use them in lieu of conditional forwarders, faster recursive queries, and distribution of zone information. Configuring DNS zone storage. Zone replication. The transfer of zone changes from one DNS server to another. For a standard zone, zone replication is called zone transfer. Active Directory integrated zones have the following advantages over a standard zone. Automatic zone replication, multi-master replication and update, secure updates. Use permissions to restrict which users can modify zone data. For me, that's a big one. Efficient replication. Active Directory zone replication scope. The zone replication scope determines which partition the zone is stored in and which DCs the zone information is replicated to. Replication scope options to all DNS servers running on domain controllers in the forest, to all DNS servers running on domain controllers in this domain, to all domain controllers in the domain for Windows 2000 compatibility, to all domain controllers specified in the scope of this directory partition. And here's your example. It just has those checkboxes like they were explaining there previously. Controlling replication to specific domain controllers. To limit replication to specific DCs, create a custom DNS application directory partition on each DC the zone should be replicated to using one of the following options. Run the add DNS server directory partition PowerShell commandlet, enter the DNS command exe, create directory partition command at the command prompt. Dynamic updates. Dynamic updates can be configured in one of three ways: secure only, non-secure and secure, and none. Remember, this sounds awfully familiar, doesn't it? An advantage of using Active Directory integrated zones is the ability to limit dynamic updates to only verified domain members. So you can see here, domain updates, have your nice little drop-down box, and then you can also set aging and scavenging properties under aging there. Configuring unknown record support. Unknown record support is a new feature of DNS in Windows Server 2016 that supports resource records of a type unknown to the DNS server on Windows Server 2016. This allows you to create resource records that are in a format unknown to Windows DNS server, but that the Windows DNS server will return in response to client queries. You can add an unknown record to a zone by using the Add DNS Server Resource Record PowerShell commandlet with the unknown option on there. Implementing DNS policies. Windows Server 2016 adds a feature called DNS policy, which allows you to manage DNS traffic, filter queries, and load balance your applications based on a number of criteria. Ways you can use DNS policies: you can create filters, manage subnet-based traffic, balance the load of applications, specify split-brain DNS. DNS policies can be applied at the server level or at the zone level. There are two primary types of policy. Query resolution policy, which specifies how DNS queries are handled by the DNS server. Zone transfer policy specifies whether a zone transfer is allowed. DNS objects you can create and manage using PowerShell commandlets. You can do the client subnet, zone scope, which is a subset of zone where a zone can contain multiple zone scopes, and each zone scope has its own set of resource records, or a recursion scope, which defines the queries which will use DNS recursion. Configuring zone scopes. For zone level policies, you need to create one or more zone scopes. One use of DNS policies is to ensure that resource records of resources close to the client, sorry, not closed, are returned by the DNS server. In doing so, the client's resources physically closer to them. And then looks like we have a nice example that should come up on it. Configuring DNS recursion scopes. DNS recursion scope, a DNS feature which allows you to specify which DNS queries will use recursion and which won't. And then use the following commandlet: set DNS server recursion scope, and then the name, and then enable recursion false. Then add DNS server recursion scope, name, internal network, enable recursion true. And now remember when we were talking about how you add these in, when you're doing these, you need to do them in order. You don't want to do the top one there and then go all the way down to the bottom. You want to start at the top when you're doing the commandlets and work through them, because each step sets you up for the next one. So you can see how in this one you do the set DNS server recursion scope, name, enable recursion false. Then you add DNS server recursion scope, name, internal network, which is your name of your internal, and then you're like, okay, now we can do enable recursion true. Add DNS server query resolution policy, name, recursion policy, and then action allow, apply on recursion scope, and then your internal network name that you have up there in the top, server interface IP, and then your IP equals IP address there. So you're just setting all of that information in a string, one piece at a time. DNS is common target for attacks such as, and we've talked about these multiple times, DNS spoofing, DNS cache poisoning, denial of service or DDoS, distributed denial of service, domain registration hijacking, and man-in-the-middle attacks. Oh, someone have a question? Ha ha ha. Yeah, I think we've talked about the DOS and DDoS in almost every single class since you guys have started. Domain name system security extension. Domain name system security extension, or DNSSEC, is a suite of features and protocols for validating DNS server response. There are 3 methods to ensure received data is secure: origin authentication of DNS data, authenticated denial of existence, which just honestly sounds like something it sounds like something out of a science fiction to me, data integrity. Zone signing uses digital signatures in DNSSEC related resource records to verify DNS responses. Zones using DNSSEC have the following additional resource records: DNS key, RR-SIG, NSEC, NSEC3, NSEC3 param, so that's parameters, usually it's short for, and then DS. Zone signing uses public key cryptography with 2 keys generated. You have the KSK, which is key signing key, has a private and public key associated with it, and then you have ZSK, which is zone signing key, a public and private key combination stored in a certificate used to sign the zone. Validating DNS responses. Okay, before I hit this, does anyone have questions other than I'm going to go back and look at it later when my brain doesn't feel like it's going to blow out my ear? Authenticated denial of existence. You what?
Where do parrots come from?
Did you say parrots or parents?
Parrots.
Is in the birdie? I do not know. I would have to go look up the lineage. I have no idea on that one. You would have to take some zoology courses, so. So validating DNS responses. When a client requests a resource record from a zone secured with DNSSEC, We're going to go through 1 through 6 here. A DNS client sends a query to the local DNS server configured in its network interface settings. If the client is DNSSEC aware, that information is included in the query message. The local DNS server sends a query to a root server and top level. The local DNS server receives a response containing the IP address of a DNS server authoritative for the zone. The local DNS server sends a query to the authoritative DNS server. The authoritative DNS server returns the resource record information requested, plus the RRSIG records needed to validate the response. The local DNS server returns the response to the DNS client with an indication of whether the response was validated. Okay, configuring DNSSEC. To configure DNSSEC in the DNS manager, right-click the zone you want to configure, point to DNSSEC, click Sign the Zone to start the zone signing wizard, and then click Next to begin. You have 3 options for the zone. So you see those down there: custom zone signing, sign the zone with parameters of existing zone, or use default settings. I am not a fan of anything that says default, as you know.
Am I the only one that literally pictures someone with a staff and like a pointy hat and he's doing zone configuration? and, and ironically, when I picture that, I picture
I'm a wizard!
like
Yes.
I literally picture like defensive zones when you're doing during football.
Now,
For
I'm not a
some reason,
sports
that's what
person,
goes through
so.
my head.
But I do like the wizard standing there. So you can continue on your wizard, and then you have the other ones here. You have your key generation. You can do generate new signing keys, or you can have pre-generated keys. Then you have your key properties, and then you have your key rollover section. That's actually probably fairly accurate. That's how I feel, German. The imagining where you have to say an incantation for 3 paragraphs, and if you mess up, you die. That is how I feel when I type PowerShell. So yeah, accurate. DNS socket.
Power.
Go
I was
ahead.
going to say PowerShell just always gives me the incantation of "You shall not pass."
Yeah,
So
pretty much. Yeah. DNS socket pool is a pool of port numbers used by a DNS server for DNS queries. Protects against DNS cache poisoning by enabling a DNS server to randomize the source port when performing DNS queries. DNS cache poisoning is an attack on DNS servers in which false data is introduced into the DNS server cache, which causes the server to return incorrect IP addresses. So to configure that DNS socket pool, a socket pool is enabled by default with the Windows Server 2008 R2 and higher. You configure the socket pool size and exclude port ranges via the DNS command.exe. To change the socket pool size, type the following: DNS command, then configure socket pool size, and then for this one, 5,000. To exclude the range of ports from 100 to 500, type the following: DNS config socket pool exclude the port range excluded, forgot the ed, port ranges 100 through 500. DNS cache locking. DNS cache locking allows you to control whether data in the DNS cache can be overwritten. An attacker can falsify update information, causing cached data to be overwritten by the attacker's data, resulting in cache poisoning. Cache locking prevents any updates to a cached record until your TTL expires. So this was specifically created to help prevent DNS cache poisoning. Configuring DNS cache locking. DNS cache locking is configured as a percentage of the TTL. If the cache locking value is 100, the data can never be overwritten. Starting with Windows Server 2008 R2, cache locking is enabled and set at 100 by default. To change the cache locking value so the records can be overwritten when the TTL is 75% expired, then you have the command things down here. DNS command configure cache locking percentage 75, set DNS server cache locking percent 75. Yep, there we go. Enable response rate limiting. So response rate limiting is a new feature in Windows Server 2016 that mitigates a type of DDoS attack called DNS amplification attack. A DNS amplification attack uses public DNS servers to overwhelm a target with DNS responses by sending DNS queries with spoofed IP addresses. The RRL is disabled by default, but can be enabled with the following commandlet. Set DNS server RRL. To set default values and the status of RRL, use the following commandlet, get DNS server RRL. And here's an example of what that looks like when you're using that. DNS-based authentication of named entities. DNS-based authentication of named entities, or DANE, is a new feature in Windows Server 2016 that is used to provide information about the certification authority used by your domain when a client is requesting DNS information for your server. This helps prevent man-in-the-middle attacks. DANE uses TLSA, or Transport Layer Secured Authentication records. You can add these records to a DNS zone. Now, this one's a nice long one. Add DNS server resource record, zone name, MCSA 2016, local, TLSA, certificate usage, domain issued certificate. Managing and monitoring DNS server management tasks. So there's delegated administration and performance monitoring and tuning, which, as anyone who works with a network knows, performance monitoring and tuning should be ongoing. Delegated administration. Members of the domain admins or enterprise admins group have full access to manage the DNS server. You may want to delegate DNS administration to an employee without allowing the broader domain administrative rights to these groups afforded. The DNS admins group in AD enables its members to manage the DNS server without giving them broad administrative rights. It is a domain local group and has no members by default. DNS performance tuning. The performance monitor has several DNS specific counters. You can see there's a bunch of different counters here. You can also monitor CPU and memory usage by DNS from Server Manager by clicking DNS in the left pane and scrolling down to performance. And you can see there's also, you can set your performance thresholds for your CPU and memory and graphic display periods. Analyzing zone level statistics. Zone level statistics provide a detailed look at how a DNS server is used. The following types of statistics are available for each authoritative zone on a DNS server: zone queries, zone transfers, and zone updates. PowerShell commandlets for working with DNS. It looks like we have a nice table coming up. So there's a table in the text that describes some of the many, and they do mean many, PowerShell commandlets for working with DNS. To display a list of all DNS-related commandlets. And this is probably one of those ones you want to remember: get command module DNS server. Looks like they don't have it listed out there, but yeah, remember that command. That's kind of like your when you're in Linux, when you type the name of whatever program it is and the help or -help -h, it'll help you get more about that. Okay. Let me stop sharing my screen here. All right, so this one's kind of short. We can either push on to the next chapter, or I can give you guys a chance to go and catch up since we already did some of the stuff last week. What would you guys like to do? You want another chapter? You want, yeah, it's like a 50-50 shot from what I'm seeing here. Okay, what do you mean by choose catch up? On your own or doing Cengage? Okay, if you want to go work on Cengage, just type Cengage. If you want me to add, we have plenty of time to do the lectures on these. Okay, that looks like a lot of people need to work on Cengage. There are extra chapters on this one for Cengage for this week. So I'd like it if you guys would go do as much as you can. There are 5 of them for this week. So please go take a look at that. I will be getting your VMs and stuff out to you this week so you can play with them. I will also be working with you guys on Friday. We'll play around with the VMs. If you want to hop on with me on Friday, we'll play with them and just mess around so you guys can do stuff too, but you'll have access to them before then. So please go work on that. Let me know if you guys have problems with Cengage. Sounds like we've had some off and on. Let me hit stop record here.